Okay, let's get started. First thing that I need you to cross out is the word Daltons, and instead write down gas. So we are doing gas law practice. Have your formulas ready, please.
What is a gas?
Job, so I want to simplify it.
Okay.
Yeah. So, but yeah, you can have it. So what I want you to write down on top is that when you change degrees, right, there's Fahrenheit. What other degrees do we have? Celsius, and then do you know any others? Okay, so let me introduce you to Kelvin. Kelvin is a degree that is used in science. So it's a degree, so you can put a little degree sign. And the way we calculate kelvins is, so let's abbreviate it to K. Kelvin is Celsius plus 273. That is your formula. So the degrees Kelvin, the way you calculate it, you take the degrees that is given to you in Celsius, and you add 273. The volume of hydrogen the volume of hydrogen collected over water is 453 milliliters at 18 degrees Celsius and 780 milliliters of mercury. What is this volume at STP? STP, let's define STP. STP means standard. S stands for standard. Temperature. And pressure. So on your exam, when you get these problems, you won't know exactly which law to use. So you have all of them ready. You need to have all of them ready. Let's see, what do they give us? Let's underline the given. Let me use green. So the volume of water is 453 milliliters. And then I have a temperature of 18 degrees Celsius, and I have a pressure of 780 millimeters of mercury. So I have volume, I have temperature, and I have pressure. I can use basically any law that I wanted to calculate this. Any law would work in some ways because I have all three things. So I have to pick one. One of the easiest ones is this guy. They're all pretty easy. Charles's law. So let's apply Charles's law to it. And you'll see Charles's law is also easy to memorize, right? Volume, initial, right? Initial volume divided by initial temperature is final volume divided by the final temperature. Or you can say V1 divided by T1 equals V2 divided by T2. Is everybody with me?
Yes.
Okay. So I'm going to box in my formula. And now I will substitute with what I have. What is my given volume, class? 453 milliliters, right? So I will write down 453 milliliters where V1 goes. What is my initial temperature?
18 degrees Celsius.
18 degrees Celsius, but do we keep it in Celsius? No. What do we change it to? Kelvin. So let's do a little side calculation. Kelvin would be 18, that's the degree, right? I'm using this formula, so Celsius plus 273. So 18 plus 273. Can somebody tell me what that is? Excellent. 291 degrees Kelvin. Okay, so I write down 291. That's my T1. Do I have a volume, or is that something that I'm looking for? Yes. So what is its volume? I will highlight that. That is like what I need to find. So instead of, I can only put down V2, right? I don't have that. And then what is my final temperature at STP? So let me show you. See the STP? STP again means that the temperature is going to be 0 degrees Celsius. That's standard temperature. So can we change standard temperature into kelvins? Let's do a side calculation. Kelvin is going to be the degrees plus 273. How many degrees do I have in a standard temperature, class? 0. So I'm going to have 0 plus 273. And what do I get? 273 Kelvin. Right? So you follow this formula. All right, so 273, so I will write down 273 Kelvin. Now, can you tell me how to figure out what V2 is? That's right. Right, so this is, you just set it up. First you get the formula, then you set it up. And now you plug it in. So 453 times 273 divided by 291 equals V2. You don't have to put it in parentheses in the when you plug it in. Okay, it's a decimal. Okay.
Yeah.
We get. Can I get a second bet? Can somebody else plug it in? Okay, let's go. So 453 times 273 divided by 291, 424. Okay, let's talk about sig figs. How many sig figs do I have here? How many significant figures is that? 3. 1, 2, 3. How many sig figs do I have here? 2. And here? 3. So my answer will be in 3 sig figs. So it will be what? 425. Yeah. Milliliters. Okay, let's look at the next one. Are there any questions? Great. Let's look at the next one. Maybe you guys can work a little bit more alone on this one. First, take a marker and underline what is given. Can somebody yell it out to me? 423 and 22 degrees Celsius. 738. So this one is my volume. This one is my temperature 1, right? Volume 1, temperature 1. And this one is my pressure 1. Do you want to use a different formula, or do you want to stick with this one? All right, what is my formula? Okay. Charles is a good one. I mean, Charles is very, very basic. Charles's law, there it is. And of course, I need to say what is the new volume. All right, so we are looking for the same thing. Okay, so now let's replace those letters. What is my V1?
It's 420. Whoa, 423.
What is my T1? Can we change that to Kelvin, please? Can you just tell me what it is in Kelvin? Can you do the calculation by yourself? 295 Kelvin. How did he get that? That's right. You can also look at the previous problem. So 295 Kelvin. Okay, do I know what V2 is, or do I need to find it out? All right, so I leave it same thing, and I divide it by what?
273.
It's at STP, right? So at STP, the temperature is 0 degrees. Transferred into Kelvin is 273. Okay, so now I'm solving for V2. So remember, you take this and you move it up. So I have 423 times 273 divided by 295. And what do you get? 391, you said, right?
Wait, many times.
Are you with me? Okay, let's see if you can do the last one by yourself. Yes. Standard temperature and pressure. So they're telling you at STPs, that means you immediately know it's going to be 0 degrees Celsius. But you also need to know that in science you change things to Kelvin. So you will have to add 0 plus 273, which is 273.
Is Kelvin actual name?
Yes.
I'm not Tyrone. The hood featuring Tyrone.
Okay, let's do the next one. Okay, so standard temperature, the temperature is 0, and the pressure will be 1 atmosphere. That's the pressure that we are on. Guys, I am recording. Please stop talking. Let's look at number 3. What is given? So we have the volume 1, and then I have temperature 1, and I have pressure, right? 1. Do you want to use a different formula, or are we comfortable with Charles?
Charles is easy.
Charles is good. Yeah, Charles is fine. So V1 over T1, V2 over T2. On your homework problems, I want to see all 3 steps. Okay, and then you just substitute, right? 400 divided by, okay, what is 30 in Kelvin? 303 Kelvin, right? We got this, right? Milliliters, this is 303 Kelvin equals V2 over 273. Okay, you guys got this now? All right, works like butter, right? Smooth. Okay, and then you plug it in, so 400 times 273 divided by 303. And what do I get for V2? 360. That is correct. And you get an A on your exam. Okay, good.
Stoichiometry. Wait,